Welcome, Geometry. We are jumping into lesson 36 today. So, the great news is lesson 36 may sound like it has some new concepts, but if you're really looking at the theorems that they're introducing to you, if you look at it in light of what we already have learned, it's just a little bit different twist on what you have already done. So I always love sharing that right from the start, because sometimes when you say we're learning something new today, it can be intimidating. Now let's look at page 230. So we're looking at right triangle congruence theorems. So specifically, we've talked about angle congruence, side, 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 angle, side, angle. So we've talked about all those, and those are not specifically when two triangles are right triangles. So what about the specific cases when two triangles are right triangles and they tell us that one of the legs, which is one of the non-hypotenuse sides, right, and then one other angle? Well, your book calls it leg angle right triangle congruence theorem. Well, friends, if you take a look at the picture, it's what we've already learned. It's just that, let me see if I can zoom in right here. So if we're looking at this picture here, so do you see that it's called leg angle? See, leg and angle of a right triangle congruence. Well, friends, that's angle, side, angle. It just so happens that one of the angles is also 90 degrees. So that makes it even easier, doesn't it? All right, take a look at this one. This is hypotenuse angle. Well, if I already know it's 90 degrees, and they've told us that the hypotenuses are congruent and another angle, well, we understand that that's angle, angle, side. So pretty interesting that a lot of these we've already looked at before, right? Down here, it tells us leg, leg. Well, we understand that if it's 90 degrees, then it would, this picture shows it very well right here. Well, it's 90 degrees and then it's leg, leg. Well, look, friends, that's side, angle, side. So it's just renaming it, but you all could also use side, angle, side if you can't remember hypotenuse, leg, or leg, leg of a right triangle. All of those are very precise, and it's good to know that it's special because it is a right triangle, but nonetheless, it's still side, angle, side. So the book went over that. It said these new concepts. So that's lesson 36, and there are 3 theorems there to look at. Now, they've also given us 5 examples to go through from page 230 all the way on to 233. And those examples there of just some proofs of how those theorems were able to be applied and used. And on page 232, there is one more theorem, theorem 36.4, and that one is hypotenuse leg. And you know that that would be side, side, angle. So very important there, that if I know that right triangles are congruent based on the hypotenuse and another leg. So very, very interesting, but also something that you can attach because you've already memorized side, 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 angle, side. So that really does help. Look on page 234. There's your lesson practice. It says, suppose that AB is congruent to DE, and AD, angle A, is congruent to angle D. Use leg angle triangle congruence theorem to prove the 2 triangles. Well, I already know that given their right triangles and then given the side, so I can use, and it says you can use leg angle. So that's very important. And you can just feel free to write those out, or if you want to write it out in a proof or a flow chart. But the book just gives us a paragraph formula that because of this, therefore I know this. Sometimes it's easy when it's asking you to prove something to make it more difficult than it is. But friends, all they're looking for is for you to reason it out. Isn't geometry great that we can think, if I am given this and I need to get here, what proves it? So that's all that they're looking for. All right, letter B, suppose AC is congruent to DF and A is congruent to D. Use hypotenuse angle triangle congruence to prove it. So again, you're doing something very similar. So they're just asking you to know that since it's given, they're both right triangles. Now, letter C, AB is congruent to DE, BC is EF. Use leg to prove. So your book says that because both of them are right triangles, legs AB and DE are congruent, and legs BC and EF are congruent. Therefore, by the leg triangle congruence theorem, because of that, then those triangles have to be congruent. And you do have to write it in proper, remember, order matters. So triangle ABC is congruent to triangle DEF. That's very important. All right, and then D and E, you're just writing out. And again, those should just be a sentence each. Don't feel like you need to write a whole massive proof or anything like that. It's just saying use those triangle congruence theorems. So don't make it more complicated than what it's asking. Now, lesson 37 jumps into parallel and perpendicular lines. Now, it's very important that we not forget some facts about parallel and perpendicular lines. Let's go to our board. So lesson 37 is talking about parallel lines. And remember, a parallel is notated that way. And we need to remember that all parallel lines have the same slope. M we abbreviate as our slope. So y equals mx plus b. That was our best friend in algebra 1, wasn't it? So m is our slope. So in the equation of two lines, let's say it would be y equals 2x plus 7. Y equals 2x minus 4. These lines are parallel, and the reason I know it is because their slopes are the same. Don't forget, in order to compare slopes, you always have to have y by itself. I've seen some standardized test questions where one of them had like a 2 in front. Well, if it had a 2 in front, you would have to divide through by 2, and that would make this 1x. So I've seen students before just go straight to it and say, oh, 2, 2, and say, oh, these are parallel. But that's not right. You always have to make sure that y is by itself. If it's not, divide through by the coefficient, then look at what's in front of x. Your coefficient is your slope. So in parallel lines, the slopes are the same. Now in perpendicular lines, where they intersect at 90 degrees, their slope equals the, because they are perpendicular to each other, it is the negative reciprocal. So in other words, if this one's 1/4, if the first slope is 1/4, you flip it, it would be 4/1 or just 4, and it would be negative. Now, if the slope on this one is negative 2/3, then the slope on the other perpendicular one would be flip it, 3/2, and because it was negative, it becomes positive. So that is very important when you're looking at slopes. So parallel lines have the same slope, and perpendicular lines have the negative reciprocal, meaning it's the flip and the opposite. One has to be positive and one has to be negative, so they'll intersect each other. Otherwise, they would not intersect at exactly 90 degrees. So that's what your book is looking at on those examples. So parallel and perpendicular lines is lesson 37. So now they've given you some examples, and I know that you all did this in Saxon Algebra 1, which is our prerequisite to geometry. So hopefully that will bring back to mind some of the things you've learned before, right? Now your book goes through some examples of those, and just spend some time going through. There's 5 examples. So I would encourage you to push pause and look over those. It asks you to graph some of them. It asks you to come up with the slope of a line that is perpendicular to it. So let's do a couple of practice. Practice A. Find the slope of lines that are parallel and perpendicular to line V. So it shows line V there. And so what I have to do is actually take those 2 points and find the equation of that line in order to make a line that is parallel or perpendicular to it. All right, so the first thing I can do, because they've given me that equation, they have not given me the equation, they've given me 2 points. So I'm going to have to use those 2 points to find my slope. So I love to just put them on top of each other and stack them and then find the slope. So it's 0,1 is my first point, and then 5,3. So your book does that, and it solves for the slope is 2/5. So a parallel line is also going to have a slope of 2/5. And it does not tell us what point it has to go through. So, it actually doesn't tell us. It just says find the slope of lines that are parallel. I'm sorry, I did not read it carefully. I was getting ready to have you start making equations. So I'm glad I reread that, friends? All right, so the question it asks is very important. So just the slope of a parallel line, the slope would be 2/5. Now, if it's perpendicular, the slope, we just flip it. Since it was 2/5, it would become 5/2. But since it was positive, it'll have to become negative. So negative 5/2. So that was super easy. We were making it more complicated, weren't we? Oftentimes we do that in geometry is we get panicked when it asks us to reason something and we can over analyze it. All right, let's look at letter B. Are the lines y equals 3x minus 2 and then 3y plus x equals 6? Are they parallel, perpendicular, or neither? Now, this is what I was talking about just a moment ago, because it's so easy to just say, well, what's the slope? Well, they're not in slope-intercept format, both of them. So we've got to take a look at that and be very careful that we're looking at it both in the same format in order to see if the slopes are the same, or the negative reciprocal if they were perpendicular. All right, so it gave us the first one and said y equals 3x minus 2. And again, this is letter B on lesson 37. All right, so the first one is in slope-intercept formula. The next one is 3y plus x equals 6. Now, don't be tempted to say, wait a minute, the in front of the x is different. Remember, we have to have y by itself. So I'm going to subtract x, and I end up with 3y equals negative x plus 6. Now, I'm not finished because I've got to get y by itself. Divide through by 3. So y equals, now that 3 has to go in here, so it's an understood 1. So it'd be negative 1/3 x, and then 6 divided by 3. Remember, we're distributing the 3 to both sides. 6 divided by 3 is positive 2. So now let's look at our slope. If this slope is 3, and this slope is negative 1/3, let's think about that. If I flipped it, it would become 1/3, positive went to negative. This equation equals perpendicular lines. And that's how we write perpendicular. It's an upside down T. Parallel, we just put 2 lines. So it's not parallel because their slopes would be the same. It is perpendicular because it's the negative reciprocal. So that's really important there. And that is letter B. Again, letter C, they do the same thing. Letter D, find and graph a line that is parallel to this and passes through the origin. So let's jump into letter D. So we did B. C is very similar to it. So I'm going to let you do that on your own. Just make sure you get them both in point slope-intercept form. So letter D, find and graph a line that is parallel, y equals negative 2x plus 7, and we're looking for parallel. So immediately we know their slopes have to be the same. Now the slope of this, m equals negative 2. That's very important. But it has to pass through the origin. Well, the origin is 0, 0. They're testing if we know what that is, right? So y equals mx plus b is our slope-intercept formula. We know that the slope has to be negative 2. Now if it passes through the origin, that would be x is 0, y is 0, plus b. So 0 equals 0 plus b. Well, friends, that means b equals 0, right? So if b equals 0, it would be y equals negative 2x, because it has to pass through the origin, so the y-intercept would be 0. Their slopes have to be the same. So this is my equation. That wasn't too difficult at all, was it? Now letter E, find and graph a line that is perpendicular and passes through the point. So let's do this again. So we just did practice D, and it was parallel. We're looking at practice E, and it's perpendicular. So it said y equals negative 4/3 x plus 3. The only thing we need out of this equation is the slope. If the slope is negative 4/3 and they're perpendicular, then the slope is going to flip, and because it was negative, it becomes positive, and it flipped. So my new slope for my second line is going to be the negative flip, or we call that negative reciprocal. So it has to go through the point 2, 3. So y equals mx plus b. X, y is 3, m is 3/4, x is 2 plus b. All right, now let's solve that. 3 equals 2/1, so I reduce that by 2, so it ends up being 3/2 plus b. I'm going to subtract 3/2, so I end up with b equals 3 whole minus 3/2. Well, if I change 3 whole, 3/1, to something over 2, that means 6/2, right? So I'm going to mark it out and say 6/2 minus 3/2 gives me 3/2 equals b. So my new equation, y equals, what's my new slope? 3/4 x plus 3/2. So this line is perpendicular to this line. How do I know? Because my slopes are the negative reciprocal, and it passes through this point. All right, that's letter E. Now letter F is similar to example 5. So I'm going to let you do that one at home, just because it's a story problem and it'll take a little bit more time. But don't let it intimidate you. It's again perpendicular and parallel lines. So that's 37. All right, lesson 38, you're going to look at perpendicular and angled bisectors of a triangle. Now, we've already talked about perpendicular lines. So if you're looking at perpendicular, remember that that's just crossing at 90 degrees. So that's all that it's saying. So lesson 38, if it tells you that it's a perpendicular bisector, then the angle that's formed is 90 degrees. But also a perpendicular bisector is going to mean that the sides that are made, that they will be congruent. So if it says it's a perpendicular bisector, it cuts it at 90 degrees and it perfectly cuts it in half. All right, so an angle bisector divides an angle into 2 congruent angles. When all 3 angles of a triangle are bisected, the point of concurrency is called the incenter of a triangle, and that's in blue. So make sure you're looking at your terms on page 244. Finding the incenter on a coordinate plane. All right, so that's where every single angle is bisected, so it's cut exactly in half. Look at theorem 38(1), and we're on page 245. If a line bisects an angle of a triangle, then it divides the opposite side proportionally. So if the angle is in half, then it cuts the side in half as well. So very important to understand that. So angle bisectors means it cuts it in half, and then the opposite side as well. Now the perpendicular bisector meets at 90 degrees. So that's the circumcenter of the triangle. And so they show you that on page 245. It shows you the circumcenter of a inscribed triangle in a circle. So that's actually pretty neat there. All right, now our lesson practice is on page 247. So it says find the incenter of the triangle. So you're just taking those angles and just bisecting them. You're cutting those angles in half. All right. Use the diagram at the right to find the length of TU. And so I understand that if UV is 4 and TW is 10 and WV is 6. All right. So we can solve those. And if you'll take a look, that's just like example 2. And example 2 is on page 245. So they're showing us there how we can set up ratios. Because remember, the triangles are similar because we've cut those triangles in half. So the ratios there are going to be similar as well. So your book shows you how to set those up. So the larger triangle to the larger, the smaller to the smaller. So just setting those up on letter B is the most important part. So I do want to encourage you guys that as you're setting things up, that you're taking that time to make sure that you're setting those up properly, because that can really, really make a difference. So it's asking us to solve certain ones. So let's plug those in. So I've got UV, and then TU, and then I've got WV, West Virginia, all right, and then TW. All right, so let's plug in what the book told us. UV, the book told us was 4, TU, and then 6 is to 10. So let's take a look at what specifically it's telling us there. So I know that UV is to TU, and that's in the smaller one, as WV is to TW, right? And that's in the larger one. So we're setting it up, and notice that I've got the U's on both sides, the W. So I've set that up so side to side, the other side to the opposite. Now I can do the cross products. So 6TU equals 40, and then I divide through by 6. So TU equals 6 into 40. And so that does not work out perfectly, and that's certainly okay. We can just reduce there. So I can reduce that by 2, so it'd be 20 over 3. And we can leave it in that format, just like we talked about in algebra, or you can give a decimal. Either one is okay. All right, let's take a look at letter C. Find the circumcenter in the coordinates. So you're just taking that, putting it on a coordinate plane, and then you're just finding the half of each angle. All right, so each one you're just cutting it in half. All right, and then letter D is just like practice example number 4. So I'm going to let you solve that story problem at home. All right, and then the last lesson that we're covering this week is lesson 39. So you can see our ratios came back into play in lesson 38. And a lot of what we're covering this week has to do with things, with things we've already learned, just applying it deeper. We've already learned the Pythagorean theorem. We're applying it a little bit deeper. We've already learned side, side, side. We're just applying a little bit deeper with 90-degree angles. So inequalities in triangles. Remember, inequalities greater than, less than. So in theorem 39.1, it says if one side of a triangle is longer than another side, then the angle opposite the first side is larger than the angle opposite the second side. So one thing I want to point out to you is the gate principle. So like, say I have a fence here, right? So here's my fence, and then I have a gate right here. All right, so so my fence is here, and my gate is right here. Now, here the gate would be closed, right? But if someone just carefully opens the gate, this angle is super small. Therefore, the side that someone can come in the gate is very small, right? So that's the gate principle. So if I want to open my gate pretty wide, notice that this angle got a lot bigger, didn't it? well, that means the side opposite it is going to get a lot bigger as well. Do you see? So how big an angle is directly impacts the opposite side. So if I pull that gate exactly this big, well, look, that makes the angle much larger because 90 degrees. I started out super small, only a little field mouse or something can get in, right? So the side was very small. Now 90 degrees, the tallest of men can get through, right? So that's very important to understand that whatever this angle is directly impacts the opposite side. So that's our gate principle there. So that's what your book is showing you. So if I have, let's say this is 90 and this is smaller, well, because this side is less than 90, then this side is going to be less than the 90 degrees, right? The hypotenuse. So the hypotenuse has to be the largest because he's 90, then this side over here with the smiley face, right? So smiley has to be less than hypotenuse. Hypotenuse has to be larger because the angle opposite it is larger as well. So that's an important concept for us to cover there. All right, so that is theorem 39, sorry. Dyslexic moment at home. So I hope you all are following along with me on page 251. So our theorems of inequalities in a triangle. All right, the measure of an exterior angle is greater than the measure of either remote interior angles. So what your book is trying to say to you is this exterior angle out here is larger than either one of these two. How come? Because every triangle is 180 degrees. Well, an exterior angle is going to be supplementary with itself. So if this is ever smaller than one of these sides, something is up, right? Because the other two should add to make this one, right? So because this angle is here, these two should add to make whatever this is. Because these three together are supplementary, and then the exterior in this is also supplementary, 180 degrees. So that's very important. So that's theorem 39.4. Don't you love how some of these are just reasoning, just making logical sense? All right, look on page 253. Order the side lengths from DEF from least to greatest. Well, I have to figure out what F is. So I know that if they've given me a triangle and they've said this is 35 and this is 85, what does this have to be? Well, I know 35 plus 85 is 120. Every triangle has 180. So I'm just subtracting, and I found out that this is 60, right? Now it's labeled at D, E, and F. Now let's talk about it. I know that D is the smallest angle. Because D is the smallest angle right here, this side opposite has to be the smallest. So it says order the side lengths. So EF is the smallest. Then middle would be 60 degrees. So the middle side is going to be DE. And then the largest has to be opposite 85, which would be DF. DF is the largest. So it said order it from smallest to largest. Don't forget to put your segment marks above it. My fault there. Order the measure of the angles. Now it's done the opposite. So it's given us a picture here. And the picture shows, it's an obtuse, right? Obtuse triangle. And it says PRQ, P, R, and Q. And then this is 41, 47, and 65. Well, let's start with the smallest. 41 is the smallest. Therefore, opposite the smallest side. So angle Q equals the smallest. All right, then 47 is opposite of P. So angle P, the largest, angle R has to equal the largest. because it's opposite the largest side. So I hope that makes reasonable sense to you as you're solving these this week. So that is lesson 39. All right. I'm super proud of you guys, and I hope that just going through these is a help to you. Now look at letter C. It shows that it's got a triangle X, Y, and Z, but it's talking to you about angle A. A has to be more than either 70 or 50 by itself because it's the exterior angle. All right. So I can figure out what Z is because it has to be 50 plus 70 is 120. Therefore, angle Z has to be 60 degrees. Well, if angle Z is 60, then the exterior angle is 120. 120 is always going to be greater than 50 or 70. So that's all your book is trying to show you. It makes reasonable sense, but it's just kind of pointing out the obvious, right? All right, the sky is up. That's pretty obvious, unless you're, not facing the right direction, right? All right, so that's all that we're doing in these lessons. It's just kind of pointing out the obvious, right? So I hope you've enjoyed this time in geometry, and I look forward to seeing you next week. Have a great week.